All right, so we will be starting section 8.2, estimating a population proportion. Your learning objectives are the following. So let's say that we had an activity of beads and your teacher or I had a container full of different colored beads. And your goal is to estimate the actual proportion of red beads in the container. So let's say we were in teams of 3 or 4 students, and how would you use a cup to get a simple random sample of beads from the container? So we could just kind of like scoop it in, shake it up, scoop it in. Each team is to collect 1 SRS of beads. Determine a point estimate for the unknown population. So once you have that bead, your sample, you could find the proportion of reds. So from there, we want to find a 90% confidence interval for the parameter P. Consider any conditions that are required for the methods you use, and then compare your results with other teams in the class. So see how you think you might want to do this. Okay, so suppose that you got an SRS of 107 red beads, and there were 144 beads of another color. So that gave you a total of 251 beads. So you could say your point estimate for the unknown proportion would be P hat, because you're doing a sample here. So P hat, which is 0.426 approximately. So how could we use this information to get that confidence interval for the population proportion P? If the sample size is large enough that both NP and N times 1 minus P are at least 10, then we can say that the sampling distribution of P hat is approximately normal. The mean of the sampling distribution P hat in this case would be P. And our standard deviation, it's going to be P times 1 minus P all over N underneath the radical. And here's a nice density curve showing. So while we don't know the actual value of P, the population parameter from our sample, if we did, we would not need to construct a confidence interval for it. Duh. Okay. So in large samples, P hat will be close to P, so we will place P with P hat and checking the normal condition. So let's go ahead. It was random. It was normal, N times P, and N times 1 minus P. Both of those values are greater than or equal to 10. And let's see, was it independent? So if there was at least, let's see, 10 times 251. So if we said that there was at least 2,510 beads in the container, then we'd be okay. So then it says, well, the teacher said that there were 3,000 beads. So we're good. Since all 3 conditions are met, we can construct a confidence interval now. So you're still like, gosh, how do we do that? Okay. Well, let's just make sure we get those conditions down. In each of the following settings, check whether or not you can even calculate a confidence interval. So are the conditions met here? An AP statistics class at a large high school conducts a survey, and they ask the first 100 students to arrive at school one morning whether or not they slept at least 8 hours the night before. Only 17 students say yes. So is it random? No, this is definitely not random. Okay, this is a convenience. They're just asking the first 100 students who got here. Okay, so the conditions would not be met to construct a confidence interval. Okay, what about the second one? A quality control inspector, a quality control inspector takes a random sample of 25 bags of potato chips. So random, met. Okay, from the thousands of bags filled in an hour. Of the bags selected, 3 had too much salt. So is this one going to be the rest of them met? So we already said it was random, so it is an SRS, so we're good to go there. What about normal? Is the normal condition met here? So n times p would be what in this case? So I got out 3, and then n times 1 minus p would be 22. And 3 is not greater than or equal to 10, so it is not going to be normal here, so we cannot do a confidence interval. All right, so just a little review from 8.1. We said a confidence interval is going to be the statistic plus or minus the critical value times the standard deviation statistic. And we know the standard deviation, and we can get the statistic. So here we're going to do our p hat times 1 minus p hat over n because we don't know p, so we can replace it with p hat. Okay? So what's left? Oops, sorry, here, move that. The definition: when the standard deviation of a statistic estimate from data, the result is called the standard error. Okay? So this right here, the standard deviation, is actually your standard error because you're using your p hat. So if it asks you for the standard error, you know that you're going to be taking the standard deviation of a statistic. All right, so if the normal condition is met, we can use a normal curve. So to find a level C confidence interval, we need to catch the central area C under the standard normal curve. So we'll be finding like that area. So for example, to find 95% confidence interval, we would use a critical value of 2 based on that 68, 95, 99.7 rule. Using the formula sheet or a calculator, we can get a more accurate critical value. So just by like estimating with that empirical rule, here if I was going to do 95%, I know that that's 2 standard deviations away. So if I'm looking for the area greater, then my critical value here, I can use a 2. So we're going to actually do a critical value. It's called Z star, and you need to get your formula sheets out. If you don't have them, go ahead and go find them right now. I'm getting mine out too. And you'll want to go to the table. The table's at the back, and look at table A. And there's actually 2 tables for table A. One below the mean for z's and one for z's above the mean. So here z is going to be the number of standard deviations you are away from the mean. And we saw 2 for this one here on this density curve because we were using the empirical rule. So hopefully you found this table A here, and it gives you all of these charts. And you could actually, gosh, I went and jumped to the T table here for you. Okay, the T is going to approximate the Z's, and we'll get into that a little bit more. But go ahead and jump over to table B so you can see the T's as well. Now at the very bottom of table B, this line right here where it has the infinity and the percentages going on, those are actually going to be as t goes to infinity. So as t goes to infinity, you're actually going to get out your z star. Okay, and this is where we're going to find our critical values for the different percentages. So 95%. More accurately, I know we rounded using the empirical rule of saying 2, but you're actually going to have a critical value of 1.96. And remember, this is one that you might just want to know by heart. I mean, it doesn't take you that long to flip to this chart. However, it's up to you. Okay. So if I was doing a 95 or 90%, 1.645 would be my critical value. All right. All right, use the appropriate table to find the critical value for an 80% confidence interval. Assume that the normal condition is met. So here we're going to go to table B again and go down to the bottom, and the critical here, the C star, is going to be with the infinity. So look above where 80% is, and right above it would be 1.282. So I can see my critical value for an 80% confidence interval is going to be 1.282. That means 80% is going to be in between negative 1.282 and positive 1.282. Okay, so that would be the interval that you're going to construct that would give you 80% confidence. Okay, once we find the critical value Z star, our confidence interval for the population proportion now becomes your statistic plus or minus that critical value we know is Z star, and then times the standard error there. All right. So if we have all three conditions met, then we can do our confidence interval. And we know that we are finding the interval under the normal density curve between plus or minus Z star. All right. Calculate and interpret a 90% confidence interval for the proportion of red beads in that container, and your teacher claims that 50% of the beads are red. Use your interval to comment on this claim. So we're going to go back to our beads. And we said we had 107 out of 251. And we checked our conditions earlier and we were good. So now we need to go find what is our critical value here for a 90% confidence level. So if we go to our chart, our table, and above the 90%, we can see it's 1.645. So we're going to use our confidence interval. So we take our statistic plus or minus our critical value. So our statistic here was our 107 out of 251. And then we had our Z star times our standard error. And here we can simplify this down. So we have 0.426 plus or minus 0.051. So we can see our margin of error is 0.051. And then you can make your confidence by adding it on and subtracting it from it. So that would give me a 90% confidence interval. So then you can say we are 95% confident that the interval from 0.375 to 0.477 captures the actual proportion of red beads in the container. So if the teacher said that it was actually 0.5 and we want to comment on that, this interval gives us a range for possible values of P, and since 0.5 is not contained in the interval, we have reason to doubt that claim. So we're going to be like, you know what, Mr. Rose, I don't think you've really counted those. I think you're just fooling us and just trying to make something up. Okay? So you definitely want to challenge that. Okay, well, what proportion of students are willing to report cheating by other students? Hopefully all of you, because you should never ever cheat. That's just horrible. It's your morals, right? Okay, so a student project put together this question to do an SRS of 172 undergraduates at a large university. You witnessed 2 students cheating on a quiz. Do you go to the professor? Out of 172, only 19 answered yes. All right, A, identify the population and parameter of interest. B, check conditions for constructing a confidence interval for the parameter. C, construct a 99% confidence interval for P and show your method. And interpret the interval in context of the problem. And I'm going to let you see how far you can get. And pause me if you want to. And then I will start going over this down. So if you want to pause me, go for it. All right. So let's see. The population is going to be undergrad college students. Okay. And my parameter, and that's going to be, let's see, parameter in this case is proportion of students who report cheating. So it is going to be P, a proportion. Okay. So then the next thing we need to do is check that the conditions are met. So let's see, is it random? It said it was an SRS, so we're good to go there. Is it normal? So we need to do n times p and n times 1 minus p. And so let's see, our n was 172 times p was 19 out of 172, which would just give me 19. So our n times 1 minus p would actually be 153. Both are greater than or equal to 10. So it is normal. And third, is this independent? So let's do 10 times the 172. Oops. And do you have at least 1,720 in the population? I would assume yes, okay? All right, so now let's just see, construct a 99% confidence interval for P. So we're going to take our parameter, or sorry, our, not our parameter, our statistic, P hat, which was 19 over 172, plus or minus our Z star. So go on your table to the 99%, and I got Z star to be 2.576 times our standard error here, which is radical 19 out of 172 times 1 minus 19 out of 172 all over 172. And you can get this to simplify down. And that was a 0. Okay? So now interpret this in context. So we are 99% confident that the true proportion of students who report cheating is between 0.048895 and 0.172. And here I have that written. Okay. So why don't you guys see if you can do this one? And I'm going to let you check your answers. And if you need help with this, let me know. So you might want to pause before you move on. And here are the answers. Okay, so you can do like a 4-step process here if you want to. Kind of helps keep you organized when you're doing this, so just kind of routinely do these steps. So state what parameter do you want to estimate and what confidence level. Identify the appropriate inference method. So you always need to state what test you're going to use. Okay, and AP will expect you to state that test out. Check your conditions. If the conditions are met, then you can do your calculations. And then always interpret in context of the problem. I know I say this over and over and over. Don't just state the general rule, but state it what it means in context of the problem. All right, so you can also do these intervals on your calculator, which is kind of cool. So on the 83 or 84, that's what I like best. I think it's a little bit easier. It's kind of up to you if you want to use your 89. But you can go now. We are finding a 1 proportion z interval when we're doing this. So if you do a 1 proportion z interval here in your calculator, so the first thing you have to do, let me get my calculator so I can go through the steps with you. You want to get your calculator out too? All right, so go second vars. Sorry, just kidding. Okay, so go to stat, S-T-A-T. Sorry about that. I'm so used to doing second vars, right? Okay, so go stat, and then go over to the test. And then you want to go to a 1 proportion z test. And yes, when we are done, you are going to know how to do all of these tests as you scroll up and down. Woohoo! All right. So do a 1 proportion. We're going to do a 1 proportion z interval here. I think I said test just a second ago, but we are actually finding a 1 proportion z interval. Hit enter. So then, I think this was for the one we just did, yeah, using the previous example. So let's say that you had 246 out of 439, okay? N is your total. X is how many out of the total were the success in this case. Then you're going to put in your confidence level. So you can put 0.95, 0.90, whatever you'd like. I'm going to go ahead and put this into 46. 439, and in this case it asks for 0.95, and if it doesn't ask, then 0.95 we've always said is the most general. Then hit calculate, and here you can see the interval is already found for you. Right there. So that's kind of nice. But I would use it to kind of check and to write these out, because AP will sometimes say, what's the setup for this interval, instead of like, what's the interval? I still think the setups are important for you. All right. Example, teens say sex can wait. The Gallup Youth Survey asked a random sample of 439 U.S. teens aged 13 to 17 whether or not they thought young people should wait to have sex until marriage. Of the sample, 246 said yes. Construct and interpret a 95% confidence interval for the proportion of all teens who would say yes if asked this question. And then go ahead and try this one on your calculator. So first off, check your conditions and make sure that they are met. Is it normal? SRS, it said, right? So it's random. Because it said it was a random sample. Is it normal? So let's do n times p and n times 1 minus p. So n times p will be 246. So n times 1 minus p is going to be 439 minus 246, and both of those are greater than or equal to 10. So we're good, it is normal. And is it independent? So let's see, I had a sample of 439 times 10. And I think that the population of US teens is definitely greater than 4,390. So our conditions are met. Let's state what test we are using. I think I went backwards in my 4-step process. Sorry. All right, so what test are we going to use? We're going to do a 1 proportion z interval. And now let's go find that interval. So in our calculator, We're going to go stat, test, 1 prop z int. Our n in this case is going to be 439, and our x was 246. And our confidence, did it say? Yep, a 95%. So go ahead and put all that in and get your interval out. And I got 0.51393 to 0.60679. And then you can interpret that. So we are 95% confident that the true proportion of teens who thought that they would wait for marriage is between 0.51393 and 0.60679. And I'll erase this work so you can see it all typed up nice and neat. Now, if you, oh, there it is. Okay. All right. Sorry. So if you'd like to try that one, then go ahead and let me know if you have any difficulty. I'm going to go on now. Here's the answers. So I would definitely want to do this one, kind of go back when it says, is it plausible that the true proportions of American teens with profiles who have posted photos of themselves as 0.75? Use your results from A. So if I got an interval here and 0.75 was not included in it, then I would definitely be thinking that something was up, okay? So it would be very surprising if the true proportion was 0.75. You could go challenge that. So you have statistical evidence that it's probably not. So this would be a really good one. Make sure you're looking through that. Okay, so again, the margin of error here is your z star times your standard error. So what we're going to do is say, let's say I wanted a margin of error smaller than something. What would my n be that I need to pick? How large of a sample do I have to go out there and find? So that's what we're going to do next, is we're going to see what we would have to pick for n in order to get a margin of error to be a certain amount. When you don't know p hat, you're always going to use it 0.5. And AP does this a lot. So star this, write something in your notes really nice and big by it. When you don't know p hat, use 0.5. Okay, and let's go ahead and see if we can set this up. So determine the sample size needed to estimate p within 0.03 with 95% confidence. Okay, and so here we didn't even know what p is going to be, so we're going to use 0.5. Well, we just discussed that, but okay. Ooh. So we are going to do our margin of error. We want it to be 0.03 or smaller, okay? So we're going to do our critical value. So if we are 95% confidence, go on your chart, go find that. It is 1.960. Okay, times our standard error here. And we didn't know p hat, so we're going to use 0.5. And our n is what we want to solve for. All right, so the first thing I'm going to do is go ahead and divide 1.6 over. So 0.03 divided by 1.96. And I'm going to math frac it so I could get something exact. That's 3 over 196. And we know 0.5 times 0.5 is 0.25. So I could go ahead and simplify in there as well. Okay, now I'm going to go ahead and square both sides. So I'm going to take that 3 over 196 and square it. So let's see, that would be 9 over 196 squared. 38416. So I get something like that. Then I'm going to go ahead and cross multiply. Three, 8, 4, 1, 6. And then I can divide by 9. All right. So this is what I got out here. And so we can't have a fraction of a person, so we are going to have to go and round up always. So we have to have at least 1,068 for our n, whatever that was that we were in data, in order to have a margin of error smaller than 0.03, smaller than or equal to. All right. Okay, in a company's prior year survey, 80% of the customers surveyed said that they were satisfied or very satisfied. Using this value as a guess for p-hat, find the sample size needed for a margin of error of 3% at the 95% confidence level. All right, so we want 0.03 to be smaller than. 95% confidence is 1.960 for your z-star times radical. And it told us here our p-hat, now we know it, it is 80. So our 1 minus p-hat would be 20%. All over n is what we're going to solve for. So take your 0.03. 0.03 divided by 1.96, which we just did. That was 3 over 196. And we definitely want to square that. So I have 9 over 38416 is greater than or equal to 0.16 over n. Cross multiply times 38416 and divide by 9. So here I see that n is going to be greater than or equal to 682.9 something, so we always have to round up. So n has to be greater than or equal to 683. So what if the company's president now wants 99% confidence instead? Determine how this is going to affect your answer. So now our critical number is going to be a little bit different. We're probably going to need a bigger survey. Let's see. So 0.03 greater than or equal to now for 99% is 2.576. Still have our 0.8 times 0.2 over n. And when I go solve here, see if you get this, I got 1,180. So we definitely need it bigger. All right. Equality for women. Have efforts to promote equality for women gone far enough in the United States? A poll on this issue by the cable network MSNBC contacted 1,019 adults. A newspaper article about the poll said, results have a margin of sampling error of plus or minus 3 percentage points. A, the news article said that 65% of men but only 43% of women think that efforts to promote equality have gone far enough. Explain why we do not have enough information to give confidence interval for men and women separately. So we do not know how many men or women were in the sample. Okay, so we just know that it was the number of adults. So we can't really set out with the two proportions, which we'll get to later, but we don't know how many men and women there were. Okay. B, would a 95% confidence interval for women alone have a margin of error less than 0.03, about equal to 0.03, or greater than 0.03, and why? Okay. So on this next one, it is going to have to be greater than 0.03. So remember, we have our critical value times our p hat times 1 minus p hat all over n. And here I know that m is going to be smaller than the total, okay, which was 1019, because I mean, it said men and women, so you have at least one man, but since you had a proportion, I mean, you're going to have more. So here, if n is smaller going on here, then what's going to happen? So if I decrease my n, I'm going to get a bigger margin of error. Because I'm dividing by a smaller number, basically. Okay? All right, school vouchers. Go ahead and see if you can do this one. And you can pause and move forward, and then you can check your answers. All right. So here's what we learned in this section. And we will start 8.3 next.